Hi, everyone. We are looking at our next section of our semester exam review, and we're going to be looking at Chapter 3, which is parallel and perpendicular lines. So we're going to be looking at what happens when we have parallel lines intersected by a third line called your transversal. And we're also going to look at the equations of lines because we took those parallel and perpendicular lines and put them on a grid and had to deal with slope and y-intercept and finding the equations and all of that fun stuff. So let's start off with our parallel lines here. Now, first thing we need, if these lines are in fact supposed to be parallel, remember they have to have the little arrowheads on those lines, matching set of arrowheads, both pointing the same direction, so that we know for sure those are my two parallels. Now, our first set, when we started comparing one angle from the top intersection with one angle from the bottom, that's when we had our different kinds of angle pairs. Because remember, guys, we have linear and vertical, but linear and vertical happen with two lines crossing. So when we deal with three lines or more, that's when we get the other options that we can have for comparing two angles. It just, again, depends on where are they sitting. Are they at the same intersection or are they at different intersections? Again, same intersection, linear or vertical. That's it. Different intersections, we have one of the five names that we're going to be looking at now. So remember, corresponding angles, they have to be in matching spots. All right, so angle 1 at the top intersection between R and T, lines R and T, is at the top left. So when I go down to the bottom intersection, again, I want the angle that's in the top left. So in this case, that is 5. So angles 1 and angle 5. Now let's say I checked out angle 4. Well, angle 4 is in the bottom left, so it has to match with angle 8 in the bottom left. So angle 4 and angle 8. We also have angle 2, which is in the top right, matches with angle 6 in the top right. So angles 2 and angle 6. And then our last one, angle 3 bottom right with angle 7 bottom right. Okay, now one of the big things to remember here when we are dealing with corresponding angles, and that is the fact that these have to be congruent. So if I know, for example, let's say angle 1 was 80 degrees, so is angle 5, because it's congruent. If I know angle 2 is 100, then I also know angle 6 is 100, because again, they're congruent. And I could go all the way around here. 4 and 8 would have the same measure. 3 and 7 would have the same measure. Now, 1 and 3 are vertical from yesterday, or from the other day. So 1 and 3 would also be 80. 5 and 7 would also be vertical, so they would have to both be 80. The same is true for 6 and 8, both 100. 2 and 4, both 100, because again, they're other vertical angles. All right, so let's take a look at our next angle pair that we have, which is the alternate interior. Now remember, alternate means opposite sides of the transversal. Interior for inside the parallel lines. So I'm going to make this a little bit bigger. So again, T, this time T is going to be our transversal. So alternate means they have to be on opposite sides of that line, line T. Now they also have to be on the inside of the two parallels. So remember, interior is the space between the parallels, while exterior would be the space outside of the parallels. So we don't have as many options here because the only numbers we have inside the parallels are 3, 4, 5, and 6. So let's say we start with angle 3. Angle 3 is on the right side of the transversal. So that means 6 is out because I need either 4 or 5. Well, 3 and 4 from the other day, those are linear. They're at the same intersection. So 5 is my option here. So angles 3 and 5. They're on opposite sides of the transversal inside the parallel lines. And again, they cannot be adjacent. They cannot be neighbors. Now let's go to the other side of that transversal, angle 4. Okay, I can't use angle 3 because it's a linear pair. So my options are 5 and 6. Well, 5 is on the same side as 4, so 5 is out. So 6 is my leftover. So angles 4 and 6. Now, like before, like the corresponding ones, these are congruent. Oh, sorry, that's a little large there. So if I know angle 4, let's say, is 100, I also know angle 6 is 100. And if I know angle 3 is 80, I know angle 5 is 80. Okay, because again, they are congruent, meaning they're going to be identical. Now, going off of alternate interior, we also get alternate exteriors. Again, alternate meaning opposite sides of the transversal, exterior for outside the parallel lines. So this time, remember, exterior is outside of these parallels. And the opposite side of the transversal. So my exterior numbers 1, 2, 8, and 7. So now it's all about where are they on that transversal line. All right. So let's say we start with angle 1. It's in the exterior. Angle 1 is on the left side of the transversal, so I need something on the right. So that's 2, 3, 6, and 7. Well, it can't be angle 2 because that's a linear pair. It can't be 3 because that's vertical. It's got to be from the other intersection, 6 or 7. And unfortunately, it can't be 6 because 6 is inside the 2 lines. So 7 is my leftover option. Now let's do the other side. Angle. This time, let's start down with angle 8. You don't always have to start at the top. So angle 8 this time is on the bottom left. Okay, it's on the exterior. So my other options can be either 7, 6, 3, or 2. Again, it can't be 7 because that's a linear pair. Can't be 6 because that's vertical. It cannot be 3 because 3 is on the interior. So 2 is my option here. So angles 8 and angle 2. And like its alternate interior cousin over there, these are also congruent. So if I know 1, I know the other. If I know angle 2 is 100, so is angle 8. All right, now let's go to our other options that we have, which are the consecutive interiors and exteriors. So again, consecutive is talking about what side of the transversal the line is on. And for this one, consecutive means same side and interior for inside the parallel lines. So this time again, we're focusing on the interior of the parallels, and they need to be on the same side of the transversal. So let's start off maybe with angle 4. All right, angle 4 is on the left side of the transversal, so I need another angle on the same side, on the left. So again, it can't be angle 1 because angle 1 is a linear pair. We've got 5 or 8. Well, it cannot be 8 because 8 is in the exterior. So 5 is my other option here. So angles 4 and angle 5. All right, now let's take a look at another pair. We can go to the other side here. Angle 6 is on the interior. It cannot match up. It's on the right side, so that's either 2, 3, or 7. It cannot match with 7 because that's a linear. It cannot match with 2 because 2 is on the exterior. So 3 is my other option. Angle 3. Now, these on the other hand, if you notice the sizes, the physical size of these angles, if we were to look at angle 3, it is an angle, based off of this example, it is an angle less than 90, making it acute. Angle 6 is an angle that is bigger than 90, making it obtuse. So we have, based off this example, these two angles are not the same size. One is acute, one is obtuse. So we cannot say that these are congruent. These consecutive ones are supplementary. And remember, we talked about supplementary at the beginning of our review. And supplementary, just to remind everybody, means add to 180. So whatever's going on at 6 plus whatever's going on at 3 need to make 180 degrees. And the same is true for 4 and 5. Whatever's going on at 4 plus whatever is at 5 have to make 180. So the same is true for our consecutive exteriors. Consecutive, again, just meaning same side. Exterior for outside of the parallel lines. So let's start with the same side. It has to be on the same side of that transversal. But this time we need exterior, so outside of the parallel. So we're looking at 1, 2, 8, and 7. So let's say we start off. Let's say we start off with angle 8 down at the bottom there. All right, so angle 8 is on the left side of the transversal. So it's got to match up with either 1, 4, or 5. So right now 5 is out because 8 and 5 are linear. 4 is out because it's on the interior. So angle 1 is my match. All right, now let's do the other pair here. We've got angle 2. Okay, angle 2 is on the right, so it's got to match with either 3, 6, or 7. So it cannot match with angle 3 because those are linear. It cannot match with angle 6 because 6 is on the interior. So the only option that's left is angle 7. And like the consecutive interiors, consecutive exteriors are also supplementary, which again means they should add to 180 degrees. So whatever is at 8 plus whatever is at 1 makes 180, and then whatever is at angle 2 plus whatever is at angle 7 make 180. Now, some of the other things we talked about with parallel and perpendicular lines are the types of slopes that are created here. Okay, are types of slopes that we have. So I like to use a triangle to review this, because when you have your 2 points and that line is going up left to right, that is your positive slope. When that line, let's make this a little bit bigger. When that line starts on the left and goes to the right, but it goes down, that is our negative slope. When our line is horizontal, when it's flat like the ground, so again, as we go left to right, that is the 0 slope. And then as the line goes straight up or down, that is the undefined. That is your undefined slope. Now, a couple of things to remember, especially when it comes to the equations. So if you have that zero slope, then remember your equation is just y equals some number. But if you have an undefined slope, all right, let me get the word in there. Undefined slopes are the x equals, and then a number for those equations. The other two definitely have the y equals mx plus b equation that you're already familiar with. So let's look at a couple of ways that we can find the physical slope when your equations are actually on the grid. So one way you can find it, if they just give you 2 points, is to use your slope formula. That is the y2 minus y1 over x2 minus x1. So we label our 2 points, x1 and y1, and x2 and y2. And then we're going to plug them into this formula. Excuse me. So y2 minus y1, x2 minus x1. So let's plug our numbers in. All right, y2 is a 1. y1 is a 0. And then we do the same thing to the x's. x2 is a 1. x1 is negative 2. So let's see what we get. So one thing to remember, if we have minus a negative like we do down on the bottom of this fraction on your denominator, that's going to have to become a plus. So now let's clean this up. 1 minus 0, a 1. 1 minus negative 2 is the same as a 1 plus 2, which is a 3. Meaning my slope, my m, is 1/3. All right, now let's see what happens if we have 2 points that are on a physical graph. You can do one of two things. You can get the coordinates of those 2 points and do the slope formula like we just did, or you can do your rise over run. So remember, we start on the left and go to the right. So if I start at the dot on the left, I have to go down 2, and then I move to the right 3. So what we did was find the rise over run. Now remember, if you have a rise can go either up or down. If we go up, that means your number is positive. If you go down, that means the number is negative. I went down, so that means the 2 should be negative. Because again, we went down 2. Excuse me. Then we went to the run. So for the run, if we go to the right, that's positive. If we go to the left, that's negative. So I went right 3, which means it is a positive 3. So now my final slope, if I simplify or reduce that fraction, negative 2/3. So remember, we can just bring that negative to the front of the whole entire fraction. It doesn't go to both, it just goes from wherever the negative came from. But again, as we write our final fraction, all the way in the front. So rise over run is very similar to doing Pythagorean theorem, where we drew that right triangle. So now let's take those slopes and look at a couple of ways that we wrote out equations. So we have the slope-intercept equation that we used a lot, and that was the y equals mx plus b. So remember, the m is what the slope came from, whether by the formula or rise over run. The b is the y-intercept. Okay, so if I have just a quick example, m is -2 and b is 3, then the only places I'm going to plug into this equation is at the m and the b. The y equals and then the x plus will stay exactly where they are. Y equals. So switch out the m for -2. The x stays where it is. The plus will stay where it is. My b is a 3, so +3. Now, if the b was negative, then we would have a subtract there instead of a plus. One of the other equations we worked with a lot was the point slope form. All right, point slope form was the y minus y1 equals m times x minus x1. So we only plugged in the y1, the x1, and then the m. We only plugged into those 3 positions. So the point that they give us, that is the x1 and y1. x1 and y1. The m is still our slope. So we're going to write out this equation. So y, oops, it's trying to change colors. There we go. So we'll start with y minus y1, which is a -2, equals. Our m is a -2 times x minus, and now I need x1, which is a 3. Now we just need to clean this up because we do have minus a negative happening. So again, minus a negative will become a plus. So my final equation, y plus 2 equals -2 times x minus 3. And that is my final. We don't have to do anything else to it. If it says leave it in point slope form, then we leave it as it is. So a couple other things to remember when it comes to parallel lines and perpendicular lines and their slopes. Parallel lines have the exact same slope. Okay, if the slope of 1 is 5, then the parallel also has to have a slope of 5. They have to have the same change, the same rate of change, the same rise over run, whatever the case may be, but they have to have the exact same slopes. Now, perpendicular lines have opposite, meaning there has to be a sign change. And reciprocal. Which means the fraction has to flip over. Okay, so there has to be a sign change. Positive has to change to negative, and the fraction has to flip over. So we'll look at some examples in just a second. So let's start with writing a nice friendly equation here. We want to write the equation of a line that is parallel to one with -3/2. So my original slope is a -3/2. So remember, parallel, symbol for parallel is 2 vertical bars. So my parallel slope has to be the same thing, -3/2. And it has to pass through the point -4, 5. So they're giving you an x1 and a y1. So they've given me a point and a slope. So I use point slope form. So that's the same, y minus y1 equals m times x minus x1. Let's plug in our numbers. So y minus y1 is 5 equals. My m is the -3/2. And x minus x1, which is -4. Now we just need to clean this up because we have minus and negative happening. And like before, it's going to change to a plus. So y minus 5 equals -3/2 times x plus 4. And there is my equation. All right, now let's see what happens if we do perpendicular. All right, so this one specifically said we had a slope of 5. Slope of 5. So we need the perpendicular. Remember, perpendicular symbol is an upside down T. So we don't visually have a fraction yet, but remember whole numbers, you can put them over 1 and there's my fraction. All right, so first thing I need to do is sign change. So positive has to become negative. And flip this fraction over. 5 over 1 is now 1 over 5. And that is my perpendicular slope. So I'm going to use that in my equation. Now we have the point 1, negative 1. So there's my x1 and y1. And we're going to plug it into the equation just like we did for the last one. There we go. Sorry, I'm just giving myself a little space here. So y minus y1 equals m times x minus x1. So y minus, we need y1, which is a negative 1, equals, we had a negative 1/5 for my slope, and x minus x1, which is a positive 1. There we go. So let's clean this up because we do have minus a negative. It just happens to be at the front this time. So y minus negative 1 is the same as y plus 1 equals, we still have the negative 1 over 5 and x minus 1 at the end. And there's my equation. Now, one last thing I wanted to review about is how to go from slope-intercept, or find the slope-intercept, y equals mx plus b, when they give you an equation that is in standard form, which is what we have here, because my x and y are in the exact same places. So standard form is what we've got. And we're going to convert this over to slope-intercept. So step 1, cancel the x part. So if I have 2x plus 3y equals 9, I'm going to cancel out my x part, subtract it over. So I still have 3y left on the left side, equals. Now, I can't just take 2x away from 9. One is a variable, one does not. So the only thing I can do is write it out. So a negative 2x, 9 is positive, so plus 9. Second step is to divide by the coefficient of y. Which in this case is the 3's. So I'm going to divide everything by 3. And let's just see what it equals. So 3 over 3 cancel out. And there's our y equals. Negative 2 over 3 will not simplify, so we just leave it as a negative 2/3. With the x, 9 over 3 simplifies to a positive 3. And there is my final. And now we're in slope-intercept. So now I could use this to figure out if something's parallel to it or perpendicular to it. Okay, guys, I hope you enjoyed reviewing a little bit about our parallel and perpendicular lines. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.